we are going to see an unsupervised ensemble clustering approach for the analysis of student behavioral patterns. Introduction. In education, identifying student behavioral patterns is crucial for improving activities and grades. Sometimes, students may experience depression or low grades leading to abnormal behavior. To identify these issues, institutions can analyze student activities like internet access, library timing, and dinner. Normal mood students may focus less on their activities, while abnormal states may concentrate more on normal activities, generating noise in output. This helps identify anomalous or abnormal student behavior. Objective of the project. Existing work used single clustering algorithms for student behavior, grouping similar data into one cluster and noise or abnormal data into another cluster. But this model may not provide accurate abnormal behavior identification. This project uses Ensemble algorithms like DB-scan and K-means, which cluster normal behavior data into a single mainstream cluster and abnormal behavior data into a noise cluster. K-means decomposes the main cluster into multiple clusters, with the cluster with the least number of records considered abnormal. Requirements needed for this project are hardware requirements: operating system of Windows, processor of i5 and above, RAM of 4GB and above, hard disk of 20GB and above. Software requirements needed are Python IDL of Python 3.7 version. We have designed the following modules to be followed to execute the project. The first module is upload dataset. In this module, we will upload the dataset. The second module is features extraction. The dataset contains non-numeric values and clustering algorithm won't take non-numeric values. So we will apply pre-processing techniques to convert non-numeric to numeric. Dataset contains 17 columns and all columns are not important. So we apply principal component analysis algorithm, which calculates importance of features and select only important features. The third module is run initial DB-scan clustering. Using this module, we will run DB-scan clustering algorithm on the dataset to generate main and noise clusters. The next module is run K-means clustering. Using this module, we will apply K-means on main cluster to further decompose into multiple clusters, and the cluster with least records will be considered as anomalous or abnormal behavior. The next module is visualize clusters. In this module, we will visualize the K-means clusters. The next module is display anomalous student IDs. In this module, we will identify abnormal student IDs. Execution of the project. To execute this project, first we need to open the Python code file. This is the dataset folder in which I have the required dataset. These are the Python main code files, and this is the run.bat file. Instead of executing the program and command line interface, we created Windows batch file to execute the project. Double-click on run.bat file. This graphical user interface will be open. With this, we are interacting with the program. Now click on Data Collection or Upload Dataset. By clicking on it, a dialog box will be open. Select the dataset and click on Open. We can see that it confirms that the dataset is loaded, and these are the top 5 rows of the dataset. We can see there are categorical variables in the data, and there are 17 columns in the data. Now click on Features Extraction. After clicking on this, in this graph, the x-axis are feature names, and on the y-axis I have feature importances. If the bar is close to 1, it means it is important feature. If the bar is close to 0, that means it is an irrelevant feature. Close this graph, and here we can see these are the top 5 rows of the data, and these are previously we had categorical variables, and now after pre-processing we have converted the non-numeric data into numeric. These are the names of 17 columns, and previously we have 17 columns, and after applying PCA it has reduced to 6. Now click on Run Initial DB-scan clustering. In this graph we can see the small black dots are anomalies or noise data, and the big big clusters are main single clusters. Close this graph, and now click on Run K-means clustering. In this graph, we can see the main single clusters are further divided into 10 clusters using k-means algorithm. Close this graph and now click on Visualize Clusters. The clusters with least number of records are treated as anomalies or abnormal students. So the cluster 1, cluster 4 and cluster 7 are the records with least number of students, and these are anomalies. Now click on Display Anomalous Student IDs. So these are the anomalous student IDs identified by k-means algorithm. The conclusion here is, using DBSCAN and k-means algorithms, the project develops an Ensemble unsupervised clustering framework for examining students' behavioral patterns. The approach discovers abnormal and common patterns using tagged dataset. Principal component analysis was utilized to extract relevant features. This method enables focused action and specialized services.
Thank you for watching video. For more projects, please visit our website www.trueprojects.in. For updates on latest project videos, please visit True Projects YouTube channel and subscribe.